In this video, I'm going to give you a situation to think about in which a random sample is being selected from a population and a sample mean is being calculated. I want you to imagine that you're an incoming freshman at a certain university, which might or might not be San Jose State, and you've been told that you're going to be paired with 100 randomly selected roommates, and these are the people that you'll be living with for your first year at the university. After hearing this information, you decide to go on the university website and look up some information about this year's incoming freshmen, just so you have an idea of what types of people you'll probably be paired with. On the website, you discover that this year's incoming freshmen, on average, spend 40 hours per week on a digital device with a standard deviation of 20. In other words, you discover that the mean hours of screen time per week for this year's incoming freshmen is 40, and the population standard deviation is 20. Um, and at this point, you've decided that you're going to survey your 100 roommates and ask each one of them how many hours per week do you spend on a digital device. And after you record that data, you're planning to calculate the mean of your roommates by adding their 100 answers and dividing by 100. You're planning to do that to get the mean of your sample of roommates. Um, and let's say that you've also decided that you want to know what's the probability that that sample mean will come out to 38 or lower. In other words, you want to know what's the probability that the mean of my 100 roommates will come out to 38 or something lower in that range. Um, so how would you calculate that probability? Well, based on what I've told you so far in this class, you're probably thinking that you would have to calculate the mean of all possible samples of 100, put them in a diagram, and make a sampling distribution, and then count the number of possible samples with a sample mean of 38 or lower in this range, um, and then divide that number by the total number of possible samples. Um, you've actually followed that process in earlier activities in our class. You've actually used that process to calculate probabilities, I think, on one of our recent activities. But um, in this situation, that process, that method wouldn't be practical, and it's actually probably not possible. Um, so you wouldn't want to use that method to get the probability of that sample mean coming out to 38 or lower for a couple of reasons. First, you don't know the data values of all of the population members. Um, for you to use this method, you have to know all of the data values of all the population members so that you can calculate the means of all possible samples and plot them in a diagram. In this situation, those data values are all unknown. Also, in this situation, the population is very large. It's not a population of 4 people or 5 people like it was in our in the last activity we did on sampling distributions. So um, in this situation, there isn't going to be just 4 or 6 or 10 possible samples. There's going to be lots of possible samples. Um, the diagram, if you tried to make the diagram, it would have many, many boxes inside of it because there are many combinations of 100 that could be selected from this big of a population. And you probably wouldn't have enough time to calculate all of them or even fit all of them on a diagram. So this method isn't going to work. So is there a better way to solve this problem? Well, there actually is a better method that can be used if the sampling distribution is normal. If the sampling distribution is normal in this situation, in other words, if it's bell-shaped, what you can do is take the sample mean of 38, which you're interested in, turn it into a z-score, and then go to the z-table to look up the probability of that sample mean coming out to 38 or less in this red area. Because if the sampling distribution is normal, then the probabilities follow the z-score, right? And they can just be looked up in the z-table. But now we're left with a couple of unanswered questions at this point. Um, so first of all, how do we know if the sampling distribution is normal in this situation if we can't create the diagram ourselves? How do we know what shape it would have? Um, Here um, I did make a little bit of a diagram here, but um, this diagram isn't anything real. It's just meant to show the concept. So we have no idea what shape it would actually have if we created it. Um, and also, how do we turn a sample mean into a z-score? Um, well, in the next couple of videos, I'm going to answer both of those questions. Um, I'm going to tell you how we would know if the sampling distribution is normal, and I'm going to tell you how we would turn the sample mean of 38 into a z-score. And a couple of videos from now, we're actually going to find the answer to this question.